What did we notice about this first equation?
It's bad.
It's bad.
Yes, there's so many X's.
There's so many X's.
Yeah.
If you set this equal to 0, oh. Thank you. If you set this equal to 0, what did you find were your excluded values? None. Okay. Because?
It's not factorable.
It's not factorable. If something's not factorable, what does it give us? Two different kinds of numbers.
Rational.
Imaginary or irrational. Okay. So this one, we would say x squared plus 1 equals 0. That's where we subtract 1, x squared, that's so tiny, equals -1. Then we square root it. What's the square root of -1? I. It's imaginary. Therefore, it does not exist on this graph. Yes.
Why can't we just factor it like we did on all the other problems?
Because what adds to 1 and multiplies to...
Other way.
What adds to 0 and multiplies to positive 1.
Oh, I was meaning like where you do like x plus 1 and then x minus 1.
Yeah, that's the difference of squares. That would be if it was x squared minus 1.
Oh, okay.
The plus 1 is not factorable. Because remember, if we did the x squared minus 1, that was what adds to 0 and multiplies to -1. What adds to 0 and multiplies to positive 1 doesn't exist. It's imaginary. Okay, but you could also check. Look at your graph. Were there any vertical asymptotes or holes?
No.
No, there were no vertical asymptotes or holes. So that checks out. What was the domain?
Negative infinity to infinity.
Because there were no excluded values.
Or they could do that fancy capital R with the line. That's probably something you guys saw last year, right?
Oh, yes.
Yeah. You just wanted to say no, but then you looked and it was yes.
Oh, gross. That was a lot faster to write than the negative infinity
Oh, yeah.
to infinity, but
Wait,
that's
what does
a
that
real
mean?
option.
all real numbers.
Yeah? It's the same thing?
Okay.
It always is like trash.
Yeah, that's a symbol for all real numbers. Okay. What does a continuous graph mean?
It means there's no holes.
Means there's no holes. What did we call holes?
Discontinuities.
Discontinuities. Avery, what did we call holes? Discontinuities. Good.
save, girl.
Yeah, good, good,
Nice
good.
Yeah.
So if there's no discontinuities, then it is a continuous graph. It goes from negative infinity to infinity.
Discontinuity, continuity, continuous. See? Yeah.
See how it relates? Okay, what were the excluded values for this one? X cannot equal -2. And then we have the domain. We see, okay, that was what? Was it a hole or an asymptote? It was a hole. Okay, because why was it a hole? Because there's a circle. But why? X plus 2 was on the top and the bottom, so I could remove it, reduce it to 1.
Remember that thing we had you repeat? Oh. Mhm.
Yes. Okay, what was this excluded value?
2.
The domain?
Negative infinity to 2 is 2 to infinity.
I don't know why, but this is one of my favorite stuff to teach.
It's an asymptote.
Or all real numbers, except for x cannot equal 2. Okay, and then was it an asymptote? Good. Because asymptotes are non-removable. Was there an x minus 2 in that numerator?
No.
No, so it was an asymptote. Yay!
Vertical asymptote.
It was a vertical.
Horizontal are not discontinuities, right? Careful.
That is correct. Yes,
Why do you have like a U when the domain might come between a
because it means union, that they go together and define the whole thing.
It's like the math symbol for and.
Oh. Are we supposed to do that?
It is mathematically correct. So tell us.
I just did a comma.
No, not a comma. If anything, don't put anything in between it.
Am I right?
Like on your,
Do you know what I'm talking about?
whatever it's called. All right, holes. This is just going to be a refresher because you guys know this. Whoa. Back here.
Oh, that was my fault, sorry.
Yeah, shh. I'm just
Sorry,
kidding.
Crystal.
What house did you get?
Ravenclaw, but she didn't know what it meant. She's never seen Harry Potter. Right?
To find a hole, we need to make sure that the function is simplified, meaning we need to factor and I don't know. Blah, blah. I really don't know what that was going for. I mean, we need to factor so that we can reduce to 1. Okay. The x-coordinate is the 0 from, okay, sorry. This is telling us how to find the coordinate of the hole, all right? So when you're listing your holes, you're going to want to list the coordinate for it. What is a coordinate?
Place on the graph.
Point on the graph, x, y, okay? So on your homework, if you see list the coordinate, make sure it's parentheses, number, comma, number. Okay,
As in like the accuracy quiz too, that's what she's giving you a hint.
yeah, go back. 4.2,
Notation-wise.
notation, notation.
Can you write it down through it?
Yes, coordinate looks like x, comma, y. So if we already know what your x value is, which is your excluded value, for this hole, okay, so your x value is the excluded value that is removable.
So we plug it into the equation.
Yes, we plug the x coordinate into the simplified equation. If we were to plug it into the not simplified equation, that would give us a 0 error. Do you agree? If we didn't simplify this first, then we would get a -2 plus 2 on the bottom. So when you're finding the y coordinate, you plug in the excluded value
So you
into the simplified equation. What is this equation simplified to?
x plus 5.
X plus
So
5.
you plug in 2. Or -2. So it's 3.
Yes. So what is the coordinate for this hole?
Uh,
Someone other than Kaden. I know you know it.
Oh, is it 0, only
No. So close.
3? Something.
Something, comma 3.
Like -2?
-2, comma 3.
Good, Maddie.
I wasn't totally.
Because we plugged in -2 into the equation, that is your x. That is your independent variable. And you got 3.
Wait, hold on. Can I have somebody, like, I haven't really heard from today. What did she just circle? What is that on the graph? I'm not sure. Coordinate point of what?
Why?
Of the hole. Good.
Oh.
Okay. Of the empty circle? Okay, so why, it's the coordinate point of the empty circle. I know, so I'm rephrasing the word hole.
Yeah.
In a
It's an
different way
empty
to
circle.
That's what I always think of every time I hear it.
Like that hole.
help.
Like we could throw a quaffle through the hole. Yes. It's quaffle. What's a quaffle?
You guys all need to go back.
Go home and watch Quidditch. Go Quidditch. That works. You could just watch a Quidditch scene of Harry Potter. You first.
It's -2 because we like crossed out x plus 2.
Yes, Maddie.
I'm really not that smart.
No, you're killing it today.
Yes.
Where did you get the -2 from?
Let's look. What are my excluded values of this equation?
Oh, so the excluded value was just the x which we plug into the equation.
Yes. Yeah. So the x coordinate is the 0 from any factor that canceled out. So it's the excluded value, which we're going to say not canceled out, reduced to 1. It's x coordinate is the 0 or excluded value that reduced to 1. So when you're finding the coordinates of your whole, someone rephrase, what is the x value? The excluded value that reduced to 1, that simplified. What was the y value? Somebody else. Keegan, what is the y value of your whole? How do you find the y value? Plug in the x coordinate. Plug in the x that we found. The excluded value that reduced to 1. Yes. Okay. What time does this class end?
52?
Oh wow, we have plenty of time.
I would do an example,
Definitely.
but I would add, find the vertical asymptote and the whole to that so that they can see the difference in the notation, since that's the number one thing they got wrong on their accuracy quiz last night.
Find vertical
Yeah.
asymptote and whole. Okay, I need everyone's attention up here. On 90% of your guys' accuracy quiz, when you were listing your x-intercepts, I saw, is that an x-intercept? No. What would it look like?
X, parentheses, number, and then 0.
Exactly. Okay, we good? What about vertical asymptote? I saw that.
X equals.
X equals. Okay.
Oh, she's doing it.
Do A. How it just disappeared? You're like, that was so fast. Okay, work on A and C. As a table. Let me know.